If you're like me and you enjoy hitting the open road, you've probably seen a pump jack along the side of the highway, slowly pumping oil out of the ground. I invented the tangent flow valve that goes deep down to the bottom of these so-called grasshoppers, reciprocating 2 miles in the ground. It's a universal valve that can be used in every oil field and improves pump efficiency and longevity. At the initial stages of my journey, it was tricky to convince experts who had worked in the field for years to trust my new technology. I got lucky when one production engineer decided to independently test my design on 100 of his wells over 1 year to see how it performed. He called me a few days after the trial was finished and reported my technology alone made his oil company an additional $7.3 million of oil production. The news then spread like wildfire through the industry, and soon every oil company wanted my downhole pump design. Every oil well in the world is different, but if they had similar properties to the one studied, and we extrapolated the numbers worldwide on every oil well, we could see an increase of oil production by an estimated value of $7 trillion per accumulative well life cycle. Extrapolating these numbers to increase the operational efficiencies and reduce emissions, it would decrease our total worldwide CO2 emissions up to 48 million tons per accumulative well life cycle. We can make a difference in our oil and gas industry better by doing 1,000 things better. When these small inventions are implemented on a big scale within existing infrastructure, they help us create a more efficient energy while reducing our emissions. We need to do more for our planet, and now is the time. Initially, my goal while attending my first year of engineering university was to build skyscrapers and beautiful suspension bridges. However, civil engineering offered fluid dynamics, petroleum, and environmental classes, which I found myself instinctively motivated to absorb all the fundamental equations. It was the dynamic nature of fluid flow that aroused my curiosity and led me into a state of going in and out of rabbit holes, emerging with a labyrinth of exciting connections, many leading back to the fundamental formulas written by the pioneers of science and engineering. My second internship position in third year engineering, I was assigned to Dr. Udo Zeidler, who was one of the rheologists working on carrying capacity index of irregular shaped cuttings in an annulus with non-Newtonian fluid behavior in 4-dimensional space. He would come into the downtown office in Calgary late in the evening, write down a bunch of detailed formulas on the board, and I would come in the morning and write them down in my notebook. And then he would send me off to the university to go do some more research. After our time together, Dr. Udo Zeidler published the most important paper at the time, helping oil companies save millions of dollars while drilling oil wells in Western Canada. The reference paper is An Experimental Analysis of the Transport of Drilling Particles in an Annulus by Udo Zeidler. Graduating president of my class with internship distinction, I was incredibly fortunate to be hired by an oil and gas service company the day I finished university. The company offered me a 2-month paid vacation, any destination I wanted in the world, if I agreed to work 2 years in the field for them when I came back. Well, I didn't hesitate for a second. I had the opportunity to work across Canada in Saskatchewan, Alberta, BC, and Northwest Territories, getting valuable field experience. Experience that included long hours, physical labor, cold weather, remote locations, and some dangerous well conditions out there. But getting a hands-on approach with a portable rheometer, a Marsh funnel vis cup, a density balance, a chemistry kit across different drilling rigs, including the Northwest Territories when you'd see minus 60 degrees Celsius weather and only 4 hours sunlight. It was an incredible experience to tie in the theoretical and practical pieces of the knowledge that I learned in university. I remember one time in Rocky Mountain House, I got an urgent call from a drilling engineer. There was a kick going on. I remember stopping on the way to the rig, and there was purple lightning across the sky horizontally. It was raining. I went over top of a bridge, and there was oil flowing down underneath me, with crews trying to fix the oil spill. It was very nervous getting onto site. The ground was rumbling. Alarms were going off. People were running and to action everywhere. The 2-inch pipe to the flare stack was bouncing on the ground from the well that was kicking. The pipe was 100 feet from the rig floor and the gas had to be ignited on the flare stack, but it was about 75 feet in the air and lit up the entire forest. Right away as I got on site, I was put into action. I had to control the rheology and the density of the fluid in order to kill the well. So to control these, I had to look at the viscous fluids to be utilized to build up the dense fluid column to balance the formation pressure. This well was also 15% sour, so with only 2% H2S, a person will suffocate and die within minutes. In the end, my training on proper fluid chemistry and fluid properties wound up controlling the dangerous well kick. A lot of high fives everywhere, and what a wild ride. After this moment, I realized I was meant to work on the technical areas of oil and gas to help protect the people, to be more proactive on the safety side, to learn the technical on a deep level, and also to reduce our environmental footprint. As my career progressed, I found myself in a position of an engineering manager for an environmental drilling fluids company. I hired an engineer with a master's degree in rheology, and one of our priorities was to help oil companies drill longer horizontal wells. This included sophisticated hydraulic programs, environmental chemical formulations, and iterative fluid dynamics to find solutions that were practical and effective in the field. Around this time in my career, I had a friend of mine from the industry approach me for some help. He was a production engineer and he was looking to solve a pump issue that he was having with his company in some of his fields. Always eager for a challenge, I built some wax molds and an apparatus to test different designs so I could understand the issue on a more practical visual manner. After 1,000 iterations, I discovered something very exciting. If I orientated the angle of the fluid flow of a Newtonian fluid in a cylindrical boundary condition around a fixed sphere, the angle tangent equal to pi came out of the data, and that angle helped maximize the flow and decrease the pressure drop. It was a eureka moment. To help take this technology and commercialize it, 2 others agreed to help with sales and funding. 3 of us partners, the engineer, the sales guy, and the money guy, started Alberta Numbered Company and built some to try on some oil wells. After a long field trial, we pulled the pump where there were no signs of wear, but the efficiency was hard to measure. Despite not having the data, we decided to risk it and build some more. We used a boots on the ground pump shop marketing strategy and started to gain momentum working in different oil fields. We sold and delivered tangent flow valves to many pump shops in Alberta. They had already liked the valve, specifically noting the longer run times. They also reported oil companies were seeing efficiencies. However, no one was able to share their confidential well data in fear of the competition getting hold of it. So after 7 years of no failures, we received an offer from a large artificial lift company, including a lump sum and a royalty for our patented product. However, negotiations fell through. As a result, the 2 partners decided they no longer wanted to go on this road and put more energy into the valve. Despite the setbacks, I believed in the technology, so I mortgaged my home, I scrounged up all the additional personal funding I had to buy out the partners. I invested money into building new molds, new marketing, more inventory, and a new vision for the company. It was a risk. Looking back, I'm really glad I took. Parallel to my work building Tangent Flow, I also became a partner of a large drilling fluid service company. In 2011, we sold it. We celebrated our good fortune before the oil industry collapsed in 2014. So the additional money from the sale of this company provided me with the opportunity to take Tangent Flow on the road. I traveled 10,000 kilometers a few times a year with a portable flow run machine in the back of my Jeep to present the efficiency and flow patterns of my invention to oil shows and presentations to the group of pump shop managers and field oil company engineers. I was looking to prove the technology in the lab to really help engineers understand how it can help them. With the stroke of luck, the flow run at the college my father worked at for 30 years had just been built, and he was able to get us access to the flow run to do pressure drop experiments. It was a brand new, beautiful $3 million flow loop to measure the tangent flow efficiencies. Our research resulted in excellent results, proving its operational effectiveness on a scientific level. I was operating tangent flow from home. As my orders increased exponentially, my garage began to swell with inventory. Concentrating my efforts on managing inventory, sales, marketing, while managing the books eventually landed me a deal with every artificial lift company in North America. After presenting at 3 trade shows from 2017 to 2019, I contacted 269 professional engineers who all gave me their contacts and information on their specific oil field issues and specifications. They wanted to run the tangent flow insert. I was inundated with requests to supply them my patented technology and help them increase their run lives and overall production. It was not soon after this that 3 of the 5 major artificial lift companies in North America were interested in purchasing my patented design. I picked the one that had the most potential for growth. I felt this technology should be utilized in every one in the world. After being plugged into Q2 ALS, one of the top artificial lift companies in the world, the tangent flow technology has gained industry-wide acceptance, and every major oil company in the world is either running it or is asking for it to be on every one of their wells. It's quite an incredible feeling to see this invention working around the globe, and with its very humble beginning, it's nice to see it dominate in the field of artificial lift. As I mentioned this before, but it's so important, these small inventions on a big scale will help us create more efficiency while reducing emissions to our existing infrastructure around the globe. We can make our oil and gas industry better by doing thousands of little things better. I'm grateful to be part of this shift. Thank you.